Hello, let's learn circular queue. Before learning circular queue, let's look at types of queue data structure. There are four types of queue: simple or linear queue that already we have seen in previous lecture, where insertion and deletion takes place at two separate end that are called front and rear. It strictly follows rule of first in, first out. Next is circular queue that we are going to learn in this video. It is also linear data structure where first index, this is important, first index comes right after the last index, assuming that indices are in circular manner, that is in round robin fashion it works. Then priority queue in which every element or data inserted in a queue always sorted as per their priority. Priorities are assigned and they are sorted as per the priority. So it does not follow first in, first out. Then double-ended queue. Double-ended queue is a special kind of queue where NQ and DQ, that insertion and deletion operation, both operation can be takes place at both the end. That is, insertion can be takes place at rear end as well as front end also. Similarly, deletion can be takes place at front as well as rear end. Before going for circular queue, let's have a look at limitation, or we can say drawback of linear queue, that insertion can done only from the rear end. So in case of linear queue, if first element, now situation is that this queue is full, so we cannot insert data. Now in this situation, if suppose first element is deleted, still it will give error that queue is full. That is the drawback of linear queue. So even after removing, front is going to point at first element, zeroth position is free, but still it will give error that queue is full. So that is the drawback or limitation of linear queue. To overcome this drawback, circular queue is used where first index comes right after last index. So here this is the zeroth or first. This immediately follows the last. So it always in a circular manner. So let's have a look at the operations on circular queue. Same operation that we learned in case of linear queue, same operations are performed here in the circular queue as well. NQ, that is insertion operation or add new data element to the queue. DQ, that means deletion or removal operation. And apart from that, peak, that is checking the element which is pointed by front, and is full and is empty operations to check status of queue, whether it is full or empty. So let's have a look at is empty function, which is exactly similar to that of the linear queue. The algorithm is that it will check value of front. If front equal -1, then it gives message that queue is empty and return true. Otherwise, queue is not empty and it will return false. So its situation may be like this in that shown in the diagram. So function, as we learned in linear queue, it is same, is empty. If front is equal to -1, it will return 1. Otherwise, it will return 0. Now, let's have a look at is full operation or function. It is bit different than that of the linear queue. It will return a true if circular queue is full, or it will return false. So algorithm is that it we have to, in case of circular queue, we check the value of front as well as rear. If front is equal to 0 and rear is equal to max -1, that means situation is like this. So in this case, it is queue is full. Now situation may be different, or if front is equal to rear plus 1. Now in case of circular queue, we know that first always follow the, or rear always follow the front. So here it is, front and rear are one after another. So that is why here value of front is equal to rear plus 1. So this situation may arise. So situation may be like this. Then we can say it is full. that time it will return true. So those two conditions, if front equal to 0 and rear is equal to max minus 1, or front is equal to rear plus 1. In this case, it will return true. Otherwise, situation may be like this. There may be some spaces available. Front is pointing 0 and rear is pointing somewhere in the queue. So that here it is 2. So it is not full. This may be one condition, or condition may be like this. Front is pointing to the last and rear may comes after it. That is, rear may be pointing here, it is 2. So one space is empty. So in this case, front is not equal to rear plus 1. So if these two situations are there, that means it is a false. So we'll check C function for this one. Int is full if front is equal to 0 and rear is equal to max minus 1, or front is equal to rear plus 1, then we return 1, else we return 0, that is false. This is full function, little bit different that of the linear queue. Now peak function is exactly similar to that of the linear queue. We just check the what is value available at circular queue, and which is pointed by front. We just check that one and display or return to the main function. Next, we talk about NQ operation in case of circular queue. So we need to consider the value of front and rear for checking whether it is full or empty or space is there. So if its situation is like this, we produce error. That means like this, as we see in is full function, or front is equal to rear plus 1, like this situation. That time we uh, give the error, overflow error, or Q is circular Q is. Otherwise, Q is not full. Now, if Q is not full, situation may be like this. Q may be empty, where we, we can understand that front is pointing to minus 1 and rear is also pointing to minus 1. That means values of front and rear both are minus 1. If it is like this, what we do? We set front is equal to 0 and rear is equal to 0. That means both will point to 0th position and we can insert a data at this position. Or situation may be like this. That means front is pointing to front is not equal to 0 and rear is equal to max minus 1. That means rear has reached to last situation, last end, and front may be after deleting, it may deleting 0 data, then first data it may be pointing, for example here it is 2. So these two spaces are there. If it is like this, so it can be understood that if, else if rear is equal to max minus 1 and front is not equal to 0, that means we have deleted some data. Then in this case, what we do, we set rear is equal to 0 and we can add data to at this position. Okay, else it could be a normal situation where front is pointing to 0th location and rear may be before the max minus 1. So there are some empty spaces. Okay, so we simply what we do, we increment rear is equal to rear plus 1 to point next location and add data to this position, that is insert new value pointed by rear, that is 88. So like this we can. Now we will see NQ function in C programming, void NQ int item, and which use is full function to check whether it is full. If it is true, it will return message, give the message queue overflow or queue is full, and return to the main program. If not, then again we check if front is equal to 0. That means to check what is the situation of front. If it is minus 1, then what we do? We set front is equal to 0 and rear is equal to 0. That is one of the situation, that is if queue is empty. Or if this is not the case, then the situation may be rear. If rear is equal to minus 1, that means rear is pointing to last position, then we make rear is equal to 0. Else we simply make rear is equal to rear plus 1. and we add circular queue, that is the array we use for circular queue, that is the above array of rear is equal to item, that is end of enqueue function. Now let's look at the deletion function, that is dequeue function on circular queue. So following steps are performed. First of all, we check queue is empty or not. If it is empty, we produce error, that is underflow error, or queue is empty. That means situation is like this: front is equal to -1 and rear is equal to -1. If situation is like this, that means queue is completely empty. In this case, we cannot delete element from the circular queue. If queue is not empty, then normal operation, that we remove data where front is pointing and then increment front pointer to point next available data, from where we can remove next data from the circular queue. But in case of circular queue, situation may be different. We need to consider different situation in case of circular queue. The one situation is that front is pointing to the only element where both front and rear may be pointing. Now here I have considered it is pointing at both location. It may point anywhere. It may point, for example, one, that means both front and rear. Now, if situation is like this, that means front equal rear. Both are pointing to the only element which is present on circular queue. So if this condition or this situation arise, then in that case we set front equal to rear equal to -1. That means after removal of that only element, Q is going to become empty. So we set both equal to -1. If not, other situation may be like that. Else, if front is equal to -1, that means front reaches to the last element, max -1. So after removal of this element, our front should reach to this first. Okay, so that is why we set, if else if front is equal to -1, then we set front is equal to 0 after removal. Okay, if not, situation may be normal situation, that is front is pointing to 0 and rear is moving away, moving ahead. And for example, in this case 2. So it is the normal case. So in this case, we remove this element and increment front is equal to front plus 1. So it will come to first position in this case. That is the normal situation. So dequeue function can be written in terms of C programming is like this: int dequeue, int item. If is empty, if it is empty, we produce underflow and exit. If not, then item is equal to circular queue array of front, that is pointed by front, that will be removed. And now we have to handle front pointer. So if front is equal to rear, that means only element is present on queue. So if situation is like this, what we do? Front equal to rear equal to -1. That means after removal of this one, queue is going to become empty. Else if situation is like that, front is equal to max -1. That means front is pointing to the last element of the circular queue. So in that case, we have to set front is equal to 0. Else it is a normal situation that front is equal to front plus 1. That means to point to the next available data and return item to the main program. This is the dequeue function in case of circular queue, where we consider multiple situations. Next is a traversal operation on circular queue. So as usual, we check queue is empty or not. If it is empty, we produce error and exit, like this situation. If queue is not empty, then we initialize variable I front, and again we check if front is less than equal rear. That means rear is ahead of front. Always we check this in case of circular queue. If it is this, like the situation is like this, front is pointing to 0th location and rear is greater than 0, then we perform following step, that is till I less than equal to rear, we process element pointed by I. Process means here in this case we display value stored at circular array and increment I till it becomes less equal I becomes equal to rear. Else situation may be like this. Front is ahead. For example, in this case, it is pointing to 2 and rear is at 0th position. So that means if situation like this means if first condition is not satisfied, means front is greater than rear. If front is f is greater than rear, then we have consider following steps. Means we set we check I or for execute following step till I less than equal to max minus 1. We process data element pointed by I. That means we set I here and execute or display data till I becomes max minus 1. Means we increment I every time we display data. And then we display then set I is equal to 0, then we should start from 0 position again. So set I is equal to 0 and perform following step till I becomes less than equal to rear. Every time, every time it should be incremented till the it is greater than equal or less than equal to rear. So that will display the data. So this display function can be written in terms of C, that is int I. If empty, produce error and return. If not, then we display content of queue. I is equal to front. If front is less than equal to rear, then while I less than equal to rear, we display content of I and increment I every time. Else, what we do while I less than equal to max minus 1, we print this content of array and increment I every time. And then in else itself, we set I is equal to 0 and while I less than equal to rear and we display content. That is the display function. So complete program for circular queue using array is the same. Circular, we define size of max 5 or 10. We declare circular array of size max. We, we set front is equal to rear equal to minus 1 and then function declaration enq deq peak is empty is full and void display. And in void main using while loop 1 to insert, 2 to delete, 3 to peak, 4 to display, 5 to quit. It is the same like that of the linear queue. This is function for circular queue.